The purpose of this build is to satisfy the many inquiries within my community about building horned enclosures. Also, I've been curious about some of the enclosures I've seen built on YouTube claiming to be horned enclosures. In my opinion, most of these so-called horned enclosures are way too small for the 12, 15, and even sometimes 18-inch drivers that they are designed for. From my experience, you have to have a tremendous amount of volume to achieve the bandwidth associated with a properly designed horn enclosure. Otherwise, you're simply building one-hit wonders. So in this video, I will build my own enclosure using a tiny 6.5-inch driver to display the true size of a properly designed horn enclosure. The goal of this build is to design a horn enclosure that plays 30 Hz lower than the subwoofer's FS rating. In my case, the subwoofer I'm using has an FS of 58.9 Hz. I plan to effectively achieve an F3 of around 30 Hz or so. So now that you know the purpose of the build and the goal of the build, what is the purpose of the video? Well, in a recent poll, I asked what type of subwoofer enclosures would you guys like to see me build? An overwhelming majority said horn enclosures. And since it's my responsibility to give you guys the content that you request, in this video I'll show you all the steps necessary to build a horn enclosure. Over the years, I've learned that it is best to design my projects in a digital space first. That's before spending my hard-earned money on building materials and such. HornResp is a free software program developed by David McBean. It is described as a direct radiator and horn-loaded loudspeaker simulator that is used for designing horn enclosures. But please keep in mind there are many different types of horn enclosures. In our case, we're designing a rear-loaded horn enclosure using a single CT Sounds Meso 6.5-inch subwoofer. Anything featured in this video, you can find links to it in the descriptions below. But first of all, what is a back-loaded horn enclosure and how exactly do they work? A traditional ported enclosure produces sound by building up pressure inside its cabin, which is then forced through a port, which in turn is tuned to a specific frequency. This type of enclosure is also known as a bass reflex design. Horn enclosures have three main parts to focus on. You have the throat, the neck, and the mouth. And you can simplify this by saying the beginning, the middle, and the end. To be more specific, backloaded horn enclosures do not incorporate a cabin in which to build pressure into. Instead, the sound waves are guided down a line and amplified by either growing or shrinking the line itself. In this style of enclosure, bass is emitted into the throat of the horn mounted at the back of the driver, and all frequencies radiate directly from the driver down the neck and out the mouth of the horn. If designed properly, not only will a horn enclosure produce more output than a bass reflex enclosure, it will also achieve this output while receiving less power. So in short, they are more efficient than a bass reflex enclosure. Our final design have a line length of 118 inches and requires 30% of the line to be treated with acoustic padding. The dampening is required to achieve a flattened response of around 30 to 70 Hertz. Once we have our measurements for port area and port length, we can then start the modeling phase of our enclosure using SketchUp. All right, guys, so right now we over here in SketchUp. And what you guys are looking at is a 3D rendering of the horn enclosure that I just built for the 6.5 inch subwoofer. As you guys can see, the port on this thing, or the line on this thing, is very, very long, and it gets progressively larger or wider as the line grows. And at the mouth of the enclosure, you have 1 foot, that's 12 inches. For anyone who was curious about that. Over here, the blue area is representing the internal volume of this enclosure, which is 3.8 cubic foot. Over here in this blue shaded area, you have how much space does the entire enclosure take up in your trunk? 5.3 cubic foot. Once again, this is a very large subwoofer enclosure for one single 6.5 inch subwoofer. Right now, what you guys are looking at is a 3D representation of the trunk space of my Chevy Impala. If you guys are curious of how much available trunk space we have, you have approximately 18 cubic foot of available trunk space. Moving on, you will see a digital representation of what this enclosure would look like inside that available space. And yes, I had to relocate my amplifier just to make this thing fit. For this build, I chose to go with MDF. Yeah, I know it's a lot heavier than plywood, but it also has a superior sound signature. For the top, the bottom, and the baffle of this enclosure, I used 3/4 inch MDF, but all the other walls and internal ports were constructed of 1/2 inch MDF. I then simply followed the cut guide developed over here in SketchUp and soon had a flat pack to assemble. I used glue and brad nails for my build and large clamps to keep everything in place. And once everything is dry and all the clamps are removed, this is what you should be left with. In terms of SPL, I have no idea what the output of this enclosure is going to be. I know that waveguide builds like this are known to be efficient, but not sure about the pressure level of them. As previously stated, the goal of this build is to design a horn enclosure that plays 30 Hz below the subwoofer FF rating. So let's grab all the necessary tools and see if this enclosure lives up to my expectations. All right, guys, so we're back here in the Impala testing the power and response of this horn enclosure. This is a single CT Sound Meso 6.5 inch subwoofer, and this is loaded into a rear firing folded horn enclosure. That enclosure measures 31 inches in length and 40 inches in width. It takes up my entire trunk. To test this, we're going to be using the mini bass meter by SPL Labs. And we have the SMD AMM1 to measure real world output. To power this system, we're going to be using the TAR amps MD 8000.1. And all of this is being fed through the LC2I by audio control. So let me find my mode for real power. We just want to monitor the power to protect the subwoofer. This amplifier would easily bust this subwoofer, and we don't want that to happen. And the test is going to involve a bass sweep. I'm going to sweep it from 150 all the way down to 20 Hertz. I want to see the response of this. And I also want to catch what my maximum decibel or SPL value is and at what frequency. That's the whole purpose of the bass sweep. So let me get this going and give it some power. So I'm gonna hit play. All right, so what we want to know now, we want to know our peak value. Right now that value is, it has an SPL value of 127.3 decibels. Now we want to know at what frequency did it get that. So what you got to do, toggle through the mode at 37 hertz. So 37 hertz is our peak. That's basically where we'll be running our test, 37 hertz. Okay, so what we're going to be doing now is we're going to be going up to 37 hertz, which is where it peaked. We're going to be running this test again. We're going to hit play and we're going to give it more volume. This subwoofer has a RMS rating of 400 watts. I'm going to try not to exceed that much because it's in an open environment. It has really no back pressure and it will damage the subwoofer in this waveguide enclosure. So what I'm going to be doing is I may just do it until it maxes itself out, and then we'll read the results of that. All right, so this is 37. That's impressive. I'm gonna put it on dyno. That's dyno power. And I'm gonna see what its peak value is. Sometimes your eyes can't see. So I'm gonna take it all the way up until it reaches its mechanical potential, till it bottoms out, and I'm gonna see what value it holds. Wow, man. That is impressive. 750 watts, and I think this thing had a little bit more in it. The ticking that I heard previous was in the environment. It came from the panels in the car, not even the subwoofer. As you guys can see, this little subwoofer has a lot of mechanical potential. And I think I'm gonna reset this. And I'm gonna take it all the way up again. Let's get it. Wow. Wow, wow, wow. And that's it. I'm gonna stop this. And we only still have a 133 dB. Very impressive for one little bitty sub. Wow. So tell me in the comments, did you guys think that this one little subwoofer would give you almost 135? I did not. It blew all the, I didn't even know it had that much sawdust in it. It blew all the